Good evening, children. A warm welcome back to you people to the Yupp Master School Foundation Program. I am Dr. Sripad Rao, a chemistry teacher. So, we are looking into the alkanes, the saturated hydrocarbons. Okay. In the previous classes, around 3 to 4 classes, we have gone through the different synthesis method or preparation methods of alkanes. We have seen the preparation of alkanes from unsaturated hydrocarbons by using the metal catalyst like nickel, palladium, platinum, and then preparation of alkanes. We have also used the alkyl halides in the preparation of alkanes. So, in the case of alkyl halides, we can employ so many different methods. If we are going with the reducing agents like zinc HCl or zinc acetic acid, we can get alkanes. And similarly, we can reduce the alkyl halides by using the strong reducing agents like lithium aluminium hydride, sodium borohydride. We can get the alkanes as a products. And we have seen alkyl halides usage in the preparation of symmetrical alkanes under Wood's reaction as well as under Frankland's reaction. So, when we are using sodium metal as a reagent, so in that case 2 moles of alkyl halides and 2 moles of metal will react in dry ether, will give us symmetrical alkane. In the case of Frankland reaction, we are going to use zinc as a metal catalyst. So, 2 moles of alkyl halides will react with 1 mole of zinc and will give us symmetrical alkane. So, symmetrical alkane preparation is possible through Wood's reaction as well as Frankland reaction. So, in both the cases, we are going to prepare a alkane having even number of carbon atoms. And then we can use alkyl halides in the Corey house synthesis for the preparation of alkane. Through this reaction takes place through the formation of the Gilman reagent or Gilman reagent formation takes place, that is dialkyl lithium cuprate. Okay, lithium dialkyl cuprate is generally called as Gilman reagent. So, that is prepared, and through the Gilman reagent it is possible for us to synthesize the alkanes. Okay. And then we have gone through the preparation of alkane by Grignard reagent. So, Grignard reagent is alkyl magnesium halide. Alkyl magnesium halide, whenever treated with a compound containing active hydrogen, in that case we are going to end up with the formation of alkanes. Okay. And we have seen the preparation method of alkanes by using one more method. What is that? The carboxylic acids, the sodium salt of carboxylic acids can be employed, coal base electrolysis process, where we are going to get alkane having double the number of carbon atoms. Okay. And in the case of the what do you call the decarboxylation process, removal of carbon dioxide from the sodium salt of carboxylic acid or potassium salt of carboxylic acid, we are going to get alkane having 1 carbon atom less than the carboxylic acid. So, all these methods are utilized in synthesizing the carboxylic acids. Okay. Now, let us focus on the properties of alkanes. So, whenever we say properties, properties can be classified as physical properties as well as chemical properties. Okay. First, let us focus on the physical properties of alkanes. So, what are the different physical properties of alkanes and how we are going to compare? So, all these things we are going to learn under this particular heading, that is physical properties of alkane. Let us see what are the physical properties that we are going to compare. So, the physical property like physical state. As you know, the matter will exist in different physical states, solid, liquid and gaseous states. So, how the alkanes are existing in nature, their physical states will be discussed. And then the boiling points of alkanes. So, what are the boiling points of alkanes and how they are fluctuated? What are the factors which are affecting the boiling point? Similarly, melting points. How the melting points can be seen for the alkanes, for the physical, as a physical property of alkane, how we are going to compare it. And then how the density is going to vary in the case of alkanes, how we are going to compare the density. And also the solubility, how we are going to use the alkanes as solvents. What is the solubility that we can expect from the alkanes. So, all these 5 physical properties we are going to discuss under the particular class, today's class. Okay. Let us first look at the physical state. So, we know the first members like methane, ethane, propane, butane, isobutane. So, all these are gases at room temperature. Here ordinary temperature and pressure means, ordinary means the room conditions. Okay. At room conditions, room temperature and pressure when we are going to take, in that case methane, what is methane? CH4 is methane. What is ethane? Ethane is C2H6 is ethane. What is the general formula of alkane? General molecular formula of alkane is CnH2n plus 2. Okay. So, CnH2n plus 2 is C2H6, and similarly C3H8, propane, butane, normal butane as well as isobutane. Both are the chain isomers of butane. So, when you take the formula, so it will be C4H10, C4H10, 4 carbons, 10 hydrogens, propane, 3 carbons, 8 hydrogens, ethane, 2 carbons, 6 hydrogens, methane, 1 carbon, 4 hydrogens. Okay. So, all these compounds, all these alkanes, methane, ethane, propane, butane and as well as isobutane are gases. So, these alkanes exhibit or they exist in nature as gases. So, the gas that we are using for the cooking purpose, the gas cylinder, cooking gas cylinder, LPG cylinder contains butane and propanes. Okay. So, hydrocarbons like alkanes are used in generating the energy. So, that energy is used when you go for combustion. Combustion means burning. Okay. When you burn the alkane, in the excess supply of alkane, we are going to get energy. So, that energy is used in synthesizing the, or that is used in preparing the food, or that energy is used in running the vehicle. How the bike is running? Bike is running because of the burning of petrol. How the vehicles are running? Because of the burning of diesel. So, burning of diesel, burning of petrol, nothing but burning of hydrocarbon only, right. So, they are going to provide energy, they are energy sources. Of course, first members methane, ethane, propane, butane, isobutane, all are gases. They exist as gases at room temperature. Then after that, up to 4 carbon atoms, they are gases, and from 5th carbon onwards, alkanes which contain 5 carbon atoms up to alkanes containing 17 carbon atoms. Alkanes containing 5 carbon atoms to alkanes containing 17 carbon atoms. That is to say that from pentane onwards. What is pentane? Pentane is C5H12. Okay. So, from pentane up to C17. So, if I write a alkane having 17 number of carbon atoms, what will be the hydrogen value? 2n plus 2. 17 2s are 34, 34 plus 2, 36. So, how many hydrogens are possible? 36 hydrogen possible. So, from pentane, hexane, heptane, nonane, decane, undecane, dodecane, tridecane, tetradecane, pentadecane, hexadecane, heptadecane. 17 means heptadecane. Okay. So, from pentane to heptadecane, from pentane to heptadecane, if you observe, all these alkanes are liquids. So, it is to say that the initial members of the alkane gases, they are gases. Okay. Initial members of alkanes are gases, but the middle members, that is alkanes having 5 carbons to 17 carbon atoms, they are all liquids at room conditions of temperature, okay, pressure, right. Under room conditions, they exist in nature as liquids. Generally, petrol if you take, it is a combination of hexane and other hydrocarbons. Hexane means 6 carbon atoms. So, they exist as liquids. So, diesel also, it is a combination of decanes and heptanes, etc. So, there also you can find they are all liquids at room temperature. Okay. Therefore, petrol and diesel are liquids at room temperature, whereas LPG cylinder, butane and propane are gases. So, you can easily remember. So, what about the other ones? So, the alkanes which are having 18 or more carbon atoms, 18 or more carbon atoms. So, alkanes which contain 18 or more carbon atoms. Okay, 18 twos are 36 plus 2 38. So, C 18 H38 onwards all are from here, all are, if you compare, they are all solids. Why the initial members are gases, middle members are liquids, and the last members or the higher members, heavier members are solids in nature. So, this can be clearly observed with respect to their masses. Okay. So, the intermolecular interaction force is also going to play a major role because of existence of the matter into solid state or maybe liquid state or the gaseous state. Okay. So, moreover, one more thing we can observe is that all the solids are colorless and odorless. Odorless means the smellless. Okay. No smell, no color is present for all these alkanes which are solid in nature. Which alkanes are solid in nature? Alkanes which containing 18 or more number of carbon atoms, they are all solids in nature. So, this is how the physical state of alkanes can be explained. Lower members, the first members are gases, middle members up to carbon 17 are liquids, carbon 18 onwards, they are all heavier members are solids. Okay. Looking at the second physical property, that is boiling point. So, how to define a boiling point? Boiling point, it is the temperature at which the vapor pressure of liquid becomes exactly equal to the atmospheric pressure, outside pressure, then only the boiling starts. That temperature is taken as boiling point. Boiling point is the temperature at which the vapor pressure of liquid becomes exactly equal to the outside pressure, then the liquid starts boiling. So, that temperature at which the boiling starts is taken as boiling point. Right. So, how the boiling point is going to vary in the case of alkanes? If you observe, boiling point of different alkanes generally increases. Boiling point will increase with what? With the increase in the molecular mass. So, with increase in the molecular mass, the boiling point is going to increase. Generally, as the number of carbon atoms increases in alkane, the molecular mass is going to increase. What is molecular mass? Molecular mass is sum of the masses of all the atoms present in the molecule. So, as the number of atoms are increasing in the molecule, what happened to the molecular mass? Molecular mass also increases. So, as the molecular mass increases, what happened to the boiling points? Boiling points also increases. So, the boiling point of different alkanes increases with the increase in molecular mass. Why it is increasing? Because of the increase in the molecular mass, what is happening? The intermolecular van der Waals forces of attraction are increasing. As the number of atoms increases, number of interactions are increasing. As the number of interactions are increasing, more van der Waals forces of attraction are coming into picture. So, when I want to boil it, what I have to do? I have to overcome this attractive forces. In order to overcome the attractive forces, I have to supply heat. So, the temperature has to be increased. So, therefore, with the increase in the molecular mass, van der Waals forces of attractions are increasing or attractive forces are increasing. As the attractive forces are increasing, the boiling points are increasing for the alkane. So, this is how we can explain the different alkanes having different boiling points, and moreover it is increasing with the increase in the molecular mass. Okay, right. And moreover, in the case of isomeric alkanes, the alkanes which are exhibiting chain isomerism, okay, alkanes which are exhibiting chain isomerism, okay, in the case of isomeric alcohols, that is with alkanes which are having isomers. Isomeric alkanes means alkanes which are having isomers. Only one isomerism is possible in the case of alkanes. What is that? That is chain isomerism. So, the chain isomers of alkanes, when you take and when you compare their boiling points, one interesting thing is observed. What is that interesting thing? So, with the branch is increasing, as the branched chain isomers increases, they generally are going to have lower boiling point. In other words, we can say that in case of isomeric alkanes, as the branching increases, the boiling point decreases. Branching, boiling points are inversely proportional to one another. So, with the increase in the branching, the boiling points will decreases. So, more branching present in an alkane less will be the or lower will be the boiling point. So, the branched chain isomers will have lower boiling points than their straight chain isomers. Why it is so? Why the branched chain alkanes are having lower boiling point? The reason is that with the increase in branching, what is happening in the surface area? Surface area of the molecule is decreasing. When the surface area of molecule decreases, the interaction forces will decrease. As interaction forces decreases, boiling point will decrease. Just now we have said that with the increase in the molecular weight, intermolecular forces like van der Waals forces are increasing, interactions are increasing. But with the increase in the branching, as the branch increases, surface area will decrease. As the surface area decreases means the interactions are decreasing. When interactions are decreasing, boiling point also decreases. So, when you take an example of 5 carbon chain, that is alkane having 5 carbon atoms C5H12. So, pentane we know it is going to exhibit 3 chain isomers. Okay. So, 3 chain isomers are possible for pentane. When all the 5 carbons are arranged in a straight chain fashion, or 4 carbons arranged in a straight chain fashion and one is taken as a branching 1 carbon, okay, or if 3 carbons are arranged in a straight fashion and 2 carbons are taken as the branches. So, in that cases we can observe 3 different chain isomers, and when you compare the boiling points you can clearly see the boiling point of pentane is 36.1 degrees centigrade, whereas isopentane boiling point is 27.8 degrees centigrade. When come to the neopentane, the boiling point is still lower, 9.5. So, what kind of information we are going to get from this one? The beautiful information that we are going to get is with the increase in branching, boiling points are decreasing. Why the branching leading to the lower boiling point? With the increase in branching, what happened to the surface area? Surface area is decreasing. As the surface area decreases, boiling point also decreases. Okay. So, with increase in branching, the boiling points are decreasing for alkanes. So, this factor has to be kept in mind for the competitive examination purpose, right. Let us show or let us watch or let us visualize the boiling points of alkanes. Methane boiling point is 111.0. Here the boiling points are given in kelvins boiling points are given in kelvins, not in degree centigrade. We know that Kelvin temperature is equal to degree centigrade temperature. Okay. Kelvin temperature equal to degree centigrade temperature plus 273.15. So, when we are going to add 273.15 to degree centigrade, we are going to get the value of temperature on Kelvin scale, that is absolute scale of temperature. Okay. So, methane boiling point is this much. What is the molecular mass of methane? 16. So, molecular mass of methane is 16, boiling point is 111. So, when in case of ethane, what is the molecular mass? It is 30. What is the boiling point? It increased. So, with the increase in the molecular mass, boiling point is increasing 184.4 kelvins. In case of propane, still the molecular mass increased to 44 from 30. So, here the boiling point, if you observe, it is 230.9 kelvins, it increased. Similarly, if you look at the butane, molecular mass is 58, boiling point is 272.4. So, still the value is increasing. So, with the increase in molecular mass, boiling point is increasing. And moreover, if you observe that boiling points are given in Kelvin temperature. So, what will be the degree centigrade? So, if I look at the degree centigrade, so degree centigrade will be 0 degree centigrade. So, here the temperature is less than 0 degree centigrade. So, at minus conditions, these people or these compounds having the boiling point. That is to say that these generally exist as gases at normal conditions of temperature and pressure. Similarly, when you look at the carbon having alkane having 5 carbons, 6 carbons and 7 carbons. In the case of 5 carbons, the molecular mass is 72, 6 carbons it is 86, 7 carbons it is 100 is the molecular mass. So, molecular mass is increasing, boiling point also increasing from 3092 to 341 and 371. So, now the temperature is coming to the around room temperature or more than room temperature. So, at room temperature these will exist as liquids. So, alkanes which are having carbon atoms 5 to 17, they are liquids at room temperature, and alkanes having 1 to 4 carbons are gases at room temperature, because their boiling points are low. So, by the time they come to the room temperature, they convert into gaseous state. Okay? Right. Next physical property is melting point. So, how we can compare the melting points here? Melting point of a straight chain alkane increases with increase in molecular mass. The same thing we can observe here, but not in a regular fashion. In the previous comparison of boiling points, methane to ethane, molecular mass increased, boiling point also increased. Then again, ethane to propane, molecular mass increased, boiling point increased. Propane to butane, molecular mass increasing, boiling point also increasing. Similarly, butane to pentane, pentane to hexane, hexane to heptane, molecular mass are increasing. So, boiling points also increasing in that case. Okay. But in the case of melting points, when you observe this physical property melting point for alkanes, melting point of straight chain alkanes increases. There is no doubt with the increase in the molecular mass, with the molecular mass increasing, the melting point is also increasing, but not in a regular manner, not in a regular fashion. There are some ups and downs are possible in the case of melting points. In some area, the melting point is increasing and suddenly decreasing and then increasing. So, we cannot observe a regular trend. Okay. A regular trend of increase in melting point not possible for the alkanes, that we can observe here. Then how it is increasing, how it is decreasing, how it is fluctuating. Increase in the melting point is more. So, melting point is increasing, in the melting point will be more when we are moving from alkane having carbon numbers from odd to even number. So, here odd number of carbon atoms and even number of carbon atoms if you take. So, in that case, when we are moving from odd number containing alkane to even number containing alkane, the boiling point increases, or sorry, the melting point increases more. Okay. Here if you observe in the case of melting points, with the increase in mass, molecular mass, the melting points of alkanes increasing, but not in a regular trend, and the increase in melting point is more when we are moving from a alkane having odd number of carbon atoms to even number of carbon atoms. Odd to even when we are moving, the increase is more observed. Okay. But the increase in the melting point is less. When it is less? When we are moving from an alkane having even number to an alkane having odd number. Okay. For example, if we know when we write a C1, C2, C3, C4, let us say we have the alkanes, okay, C1, C2, 3, C4. So, we know here we have only one carbon atom, carbon number is 1, so it is odd. Here 2 carbon atoms, 3 carbon atoms, 4 carbon atoms. You know what is even number and what is odd number. Okay. So, when we are moving from odd number to even number, when we are moving from odd number of alkane having odd number of carbon atoms to alkane having even number of carbon atoms, increase is more in the melting point. Okay. But when we are moving from alkane having even number of carbon atoms to odd number of carbon atoms, the increase is less. The increase in melting point will be less. So, that is what a beautiful information we can observe from melting points of alkanes. So, melting points of alkanes if you take, it is clearly indicating that whenever we are moving from alkane having odd number of carbon atom and to even number of carbon atom, the melting of the alkanes is more, or the melting point of alkane is more. But when we are moving from an alkane having odd number of even number of carbon atom to odd number of carbon atom, in that case the increase is, melting point increase is less. So, this point you have to keep it in mind for the competitive examination is concerned. Okay. So, let us see how the melting points are given for the different alkanes. So, when you observe methane, we know its molecular mass is 16 and ethane molecular mass is 30. So, when we are moving from methane to ethane, you can just observe the boiling melting point is increasing 90 to 101. Okay. And when we are moving from ethane to propane, the value is decreasing, it is becoming 85.3. And when we have a butane, when we are moving from propane to butane, again the melting point is increasing. In other words, we can say that alkanes having odd number of carbon atoms, having less melting point. Alkanes having odd number of carbon atoms, the melting point values are less, whereas the alkanes having even number of carbon atoms, their melting points are more. Okay. Let us also compare with the higher members as well, C5, C6 and C7. So, here if you observe the pentane, hexane and heptane molecular masses 72, 86 and 100 respectively, and their melting points if you observe in kelvins, okay, all the values are given in terms of Kelvin only, Kelvin temperature. So, if you observe here from pentane to hexane, it is increasing, and hexane to heptane also it is increasing. But when we are moving from odd to even, the value increase is more, even to odd value, the value increase is less. So, these two parameters can be easily observed. First is an alkane having even number of carbon atom is having higher melting point, and odd number of carbon atom is having lower melting point or less melting points. And when we are moving from an alkane having odd number of carbon atoms to even number of carbon atoms, the increase in the melting point is more. Okay. And similarly, when we are moving from an alkane having even number of carbon atoms to odd number of carbon atoms, the increase in the melting point is less. Okay. Less increase is possible. And generally, what we expect is with the increase in the molecular mass, as the mass increases, as the number of atoms increases, whether it is a boiling point or melting point, both should increase. Of course, in the case of boiling points, it is exactly matching with what we are expecting. With the increase in the molecular mass, the boiling points are increasing. But in the case of melting points, it is increasing, but not in a regular trend. Sometimes it is decreasing and sometimes it is increasing. We have seen in the first four that ethane and butane are having more melting points compared with the methane and propane. And when we compare pentane, hexane and heptane, when we are moving from an alkane having even number of odd number of carbon atoms to even number of carbon atoms, the increase is more. Even number to odd number, the increase is less. So, these 2 points are observed from the melting points of alkanes. And by this time, one question should come to your mind. What is that? Why the alkane having even number of carbon atom is having more melting point? Why it is so? An alkane having even number of carbon atoms, in the previous table we have seen ethane and butane are having more melting points. Why the alkane having even number of carbon atoms is having more melting point? What is the reason? So, the reason we can predict, or the scientists who have they have concluded that the alkane which is having even number of carbon atoms, okay, alkane with even number of carbon atoms, So, here if you observe, the packing takes place neatly, packing is very well takes place in the case of alkane having even number of carbon atoms. So, the packing is efficiently taking place for an alkane having even number of carbon atoms. So, when we have a even number of carbon atoms, so the packing is neatly taking place between the molecules. So, the packing is very efficiently taking place. Since the packing is efficiently taking place, when I want to melt it, what I have to do? I have to give more amount of energy to make the molecule to move apart. Okay. Since the packing is efficient means the forces of attraction, interactions are more. Since the interactions are more, the melting point also coming out to be more. So, therefore, an alkane having even number of carbon atoms will have more melting points compared with the alkane having odd number of carbon atom. The same thing, same region can be taken when increase in the melting point is more when we are moving from odd number to even number, because here the packing is going to be efficient packing taking place. So, the melting point is more. When we are moving from even to odd, in that case the increase is taking place because of the increase in the molecular mass, but increase is very less. Okay. So, the reason is alkane with an even number of carbon atoms pack efficiently. When packing is efficient, automatically the melting points will be more only, right. Next physical property is density. So, when we look at the density of normal alkanes increases with the increase in molecular mass. Okay. Density, we know density can be given as density D equal to mass by volume. It is the ratio of mass to volume. Ratio of mass to volume is density. So, in case of alkanes, if we are going to calculate the density of normal alkanes means all the carbon atoms are present in a straight chain. So, straight chain alkanes, in the case of straight chain alkanes, when you compare the density with the increase in the molecular mass, density also increasing. As the molecular mass increasing, density of the alkane also increasing. That is what is observed. But what is the maximum value we can expect? It will reaches a maximum value, limiting value of density 0.8 gram per ml, 0.8 gram per ml. So, here we are going to get the density maximum as 0.8 grams per ml. Mass is measured in grams. Okay. Volume is taken in terms of milliliters ml. So, it is gram per ml. Okay. Or you can write this is as a gram per ml, can also be taken as centimeter cube. So, 0.8 gram centimeter to the power minus 3. Okay. So, in terms of ml you can write, or you can write in terms of centimeter cube. So, the density of normal alkanes, straight chain carbon containing alkanes increasing with the increase in the molecular mass, and it is reaching a maximum value of 0.8 gram per centimeter cube, 0.8 gram per centimeter cube. Okay. One thing we can observe here. So, the maximum value of density for an alkane density, if we observe, it is coming out to be maximum value is 0.8 gram per ml. Okay. But when you take the water density, what is water density? Density of water is 1.0 gram per ml. What is the density of water? Density of water is 1.0 gram per ml. But alkanes having a maximum value, generally value will be lower than this one. Maximum value what we can expect is 0.8 gram per ml. Therefore, we can say which is denser, water or alkane? Water is denser. That is to say that alkanes are lighter than water. Alkanes are lighter than water. The density of alkanes is lower than water. Water is more dense compared with the alkanes. That is what information we can expect. Water density is 1 gram per ml or 1 gram per centimeter cube. All alkanes are heavier than air. When you compare air and alkanes, so density of air, if you take, density of air is less than the density of alkanes. That is to say that alkanes are heavier than air except methane. Methane density is lower than the density of air. So, therefore, methane is lighter than air. Are you able to follow? Here if you compare the densities are increasing for the alkanes with the increase in the molecular mass, there is no doubt. And first thing, and what is the maximum value we can expect as a density for the alkanes? Maximum value of density for alkanes is coming out to be 0.8 gram per ml. Okay. And when you compare the water density, water is 1 gram per ml. So, which is more? Water density is more. That is to say that water is more denser than alkanes. In other words, if I say alkanes are lighter than water. Alkanes are lighter than water. But when you compare with the air, density of air is still lower than that of the density of alkanes. So, therefore, alkanes are denser or heavier than air except the methane. Methane is less weight than compared with the air. So, density of methane is lower than that of the air. So, from this discussion what we can compare? Density of air is less than density of alkanes, okay, which is less than density of water. So, air, alkane, water if you compare, which is denser? Water is denser. Which is lighter? Air is lighter. Which is intermediate between air and water? Alkanes. So, this information we can get from the physical property density of alkanes, okay. And when we look at the solubility, alkanes are almost non-polar. Why they are non-polar? What do you mean by polar? Polar in the sense, whenever we say polar, it indicates that it contains poles. Poles means what? Positive and negative charges. What do you mean by pole? Pole means here positive as well as negative charges, okay. So, positive and negative charges if they are present, then we can take it as polar, okay. Then we can take it as polar. So, alkanes are non-polar. Non-polar means they do not have positive and negative charges. No positive and negative charges are present in the case of alkanes. Why the alkanes are non-polar? Because alkanes we call them as hydrocarbons. What are they? Hydrocarbons, saturated hydrocarbons. What are the components present in alkanes? Carbon and hydrogen, both are present. When you compare the electronegativity of carbon and hydrogen electronegativity is approximately the same. We can take the electronegativity of carbon and hydrogen as same. When the electronegativity of carbon and hydrogen is coming out to be same, so we cannot expect the withdrawal of electron density from one another. So, when we, for example, when I write the molecule methane this way, okay, carbon with 4 hydrogens. So, here the electronegativity of hydrogen and carbon are approximately same. So, the bonded pair of electrons will not be moved more towards the carbon or more towards the hydrogen. Where they are present? The electron, bonded pair electron is present exactly at the center position of carbon and hydrogen. It is located in the middle of carbon atom and hydrogen atom, not near to hydrogen, not near to the carbon atom. So, we cannot expect the polarity, we cannot expect the formation of poles. Poles means positive and negative charges, okay. So, we cannot expect the formation of positive and negative charges in the molecule. Since there is no positive and negative charges formation taking place, so what is happening? They are non-polar. So, alkanes are non-polar and generally they are going to be used for the solvent purpose. Student, I think you have got the clear idea about the physical properties so far what we have discussed. We have some more little explanation with respect to the solubility. We are going to discuss the solubility properties of alkanes in the next class. Until then, have a nice time. Thank you.